удаленное исполнение кода на умных устройствах от Jiashui Wang и Tianxiang Li. Поприветствуем их.
Good afternoon, everyone. I'm very happy today with my partner, Dragon, to come to ZeroNights to share our presentation. The subject of our presentation is getting remote code execution in your smart devices. We will focus on some remote attack services about smart devices and introduce some cases. First, let me introduce us briefly. Our module experience includes mobile security and mobility hunt. Okay, a brief look at today's agenda. First, I will introduce the first section, dig into the remote attack services, and then my partner will share the rest of the next section, remote attack cases found in the past and common remote attack cases, and conclusion. First of all, I will introduce how to dig into the remote attack services. Why we choose remote attack services? As we all know, remote attack service is the most attractive, and rewards programs on remote vulnerabilities are also very expensive. Zero Team add famous social apps to their bounty programs, such as WeChat, FB Manager, WhatsApp, and payouts for remote code execution is up to $500,000. Google Play is working with the independent bug bounty platform HackerOne and the developers of popular Android apps to implement the Google Play Security Reward Program. The scope of this Google Play Security Rewards is limited to RCE. Okay, this is the redeem payouts for mobile. We can see Google Play Security Reward Program, RCE vulnerabilities that allow an attacker to run code of their choosing on a user's device without user knowledge or permission. Next, I will talk about remote attack service of Android phones, Android apps, and IoT devices. First, the remote attack services of Android phones. We briefly list the 6 attack services we researched before. URL scheme and system apps. This is also a common attack chain in Android phones, and lots of mobile Pandong cases or targeting them. Baseband, WebView, and Stage Fright. There have been many vulnerabilities before. And the baseband attack was seen to us in this year mobile Pandong, and Bluetooth stack, Wi-Fi chipset, and so on. Second, the remote attack services about Android apps. We have researched many attack services of Android apps before. Attack the file operation, desk class loader desk in SD card, file observer, and the zip entry path traverser. Attack WebView, add JavaScript interface, use tasks and use Chromium Day. Attack secure cipher, load extension, and path traverser, and SQL injection. And what's more, for example, Java deserialization, open port with risky operation. And at last, the remote attack services of IoT devices, for example, full access control of server through Android app connect to device image, protocol break from Android app to server, some common BLE security vulnerabilities in IoT. Okay, these are some remote attack services about Android phones, Android apps, and IoT devices. Next, my partner Dragon will continue to share. Thanks.
Okay. So the next, first we'll see the WebView case, which is fixed in Android version 4, so it can't be used anymore. But this is a typical case, so we can have a look. We can see that this activity is exported and define an UR skin. This skin is 酷化, and the host is 酷化 client. And also it defines a category of Android.internet.category.browsable. This means it will be launched from browsable, from browser. So after it will use this get data function to receive data from the URL. It will use intent.getStringExtra to get the URL and the title. So the URL and the title is user controlled. And then it use add a JavaScript interface to inject a Java object to web page. So we can use this POC to launch it from the from browser. So next we can have a look at this demo. After browsing this website, you will execute our payload to get a remote share. Okay, this is the WebView case. So this is a typical case. Now the third part is common remote attack cases. First, for the start, we'll study a WeChat remote code execution case, which is great enough to learn. WeChat, which is the most popular social apps in China, and ZeroNights has added to their bounty program. This case mainly involves in SQLite load extension feature. WeChat use this use SQLcipher to SQLcipher for privacy information and information encryption and storage. And the SQLcipher set load extension by default. So combined with SQL injection vulnerability, we result in remote code execution. Now let's have a look at the attack process. First, the attacker will hook the WeChat send message interface. And then he will send a file with a mailphone path to the target. This is step one. And then the victim will receive the file and then trigger path traversal vulnerability and store the malicious file into WeChat app's internal path. And the step two, the attacker will send a message with a secure injection payload. Then the victim will receive a message and trigger a secure injection vulnerability and load the file stored in step 1 with a load extension. So you will connect a remote shell to the attacker. To simplify the attack process, we write a small code to a small demo to help you to understand this attack. So this Java code have a secure injection vulnerability, and then we will use this payload to attack it, and this C code is the payload which meets the code standard of the SQLite extension standard. After running this program, we can see the logcat, which means the SO file has been loaded. So this attack, the attacker just sent 2 messages, and the victim will be attacked by remote without users notice. So this is a good exploit. So I think it will meet the standard, being the standard of the ZeroNights. Next, let's have a look at the Android browser apps remote attack case. In China, Chinese vendors developed Android browser apps based on Chromium, and they customized with nice experience for Chinese users, and even use this browser engine to replace the web view of Android system. But they can't catch up with the security updates of the Chromium, so there are dozens of end days to attack. Now let's have a look, have a quick view of one of these vulnerabilities. After browsing a malicious website, the victim's cookie will be stolen by the actor. This vulnerability is a U*SSXX vulnerability, and there exist dozens of these types of end-day vulnerabilities, and almost all of the Chinese Android browser apps are affected by end-day attack. The next is a file observer remote attack case. So many apps will use file observer to monitor a scheme's resource file, which is ZIP format. And then if the directory for listening is a SD card, you will be attack controlled combined with a ZIP entry vulnerability. You will be attacked by remote. So if the path is like this, you will then we can force the browser to download the scheme file to SD card and trigger the vulnerability to get remote share. So this is a bad design. Now look at this small Python code snippet. We can use this code to create a malicious file, and then force browser to download the scheme file to SD card. Then the scheme file will be unzipped to cover the live GIF with malicious file, so we can get a remote share. Now comes the stage fright. We know stage fright is a call function that apps call whenever they need to render audio or video. So researchers have developed a metaphor of fast and reliable and stealthy exploit for the stage fright vulnerability that can affect millions of Android devices. Whether or not the attack becomes widely successful will depend on how seriously carriers and manufacturers react to this threat. We also found some stage fright vulnerabilities, and look at one of these. So this is the crash stack, and then this the POC files. We just modified this 4-bit data, and then it will result in an integer overflow. So this is the fix of Android. So if the size of the M buffer size and the M buffer count actual are not well checked, it will result in an integer overflow. So it can be exploited by remote. Now the Bluetooth remote attack case. We all know the Bluebone attack is popular among the last 2 months. We also dig into this attack surface, and we found some 0 days. This is the crash log of one of our vulnerabilities. We can see the PC address is controlled by 0017171717, and this vulnerability is not fixed yet. So we will not disclose the detail this time. Maybe next time. And then the remote install apps in Android phones. Now we can see the App Store's apps in this phone. It has an activity which is exported, and then it defines a skin and a browsable category, so it can be launched from the browser. Look at the code of this activity. If the action type equals H5 interface and the method parameter is download, it will download from the URL we controlled and silently installed. We also found lots of Android phones in China exist silently install vulnerabilities. As the vulnerabilities are not fixed, we will not disclose the details this time. We will disclose the details after they are fixed. So this is the POC. It can just it can trigger by browsing and malicious website. And in the past time, our team have found CVEs about Android and iOS systems as follows. We also found lots of mobile phones exist silent install vulnerabilities. So our next plan will target at HTC, LG, Samsung, and Google Pixel. Now, this is a demo. After receiving a message and click the website. Yeah, we will silently install an application, and we have stolen the pictures in the phone. So the next is about open port. See this example. This activity, this application open port at 6666, and then it will receive data and then handle it. We can see if we from line equals v2 dot read line, and then if line starts with jump to, we'll send broadcast to start this activity. So if the line is terminate, it will keep here process. And if the line is information, it will get the information of this Android phones. If the line is score, you will get the score, the running score of these phones to the attacker. And then if the line is version, you will get the application version to the attacker. So if we use these vulnerabilities, we can have the information about the Android phones of the attacked from the victim. So the attacker will use apt attack to this attacker. And this is the small Python code snippet of the attack we list above. So next is about a remote full access control of children's watch. As we all know, the children's watch is very popular among Chinese kids. The kids can equipped with this children's watch. The kids can communicate with their parents anywhere and anytime, and the parents can get the geolocation of their kids, make a phone call to them, and so on. If the criminals combine to any case watch, they can adapt the case easily. So we can have a look at the normal watch bind procedure. First, if the watch admin want to invite their like the grandfather or grandmother of the case, he will send the bind number to their to the kid's grandpa, and then search the grandma will search the bind number of phone number and the request to bind to the kid watch, and then the server will ask the watch admin if agree to add this person. If the watch admin agrees, it will watch admin will agree if the watch admin agrees the request, it will send a message to the server. Then the server will grant authorization to access the key watch. So this person will access to the kid's watch, has the ability to get the geolocation of the kids, make a phone call to the kid. Now, how to get remote full access control? So first we can capture the packet of the bind agreement from the watch admin to the server. So this is the packet below. We can see the mobile ID, which is the phone number of the admin, and then the watch ID is the watch ID of the kid's watch. So how to break it and bind any kid's watch with a phone number? As there is a sign to verify whether the packet is valid, and the encrypt algorithm is too complex. We can use intra-spy to break the encrypt algorithm. So we should get the watch ID of the kid watch, and the mobile ID is our mobile phone's ID, and test if there is a broken access control vulnerability. So how to get the question is how to get the watch ID of the kids. And this is tricky. This is so we can add the mobile phone or the watch. Well, we want to attack to the phone book. We can have an amazing breakthrough. And there's an import phone book interface. We return the watch ID and the bind number. This is very stealthy. So if we add the number to the phone book, we can see this interface will return the watch ID and the bind number. So this is a critical info leak vulnerability. So So now we have the watch ID by adding the phone number to the phone book. And there indeed exists broken access control vulnerabilities. And the server doesn't verify if the account ID is the admin. We can send this packet to the server. And now we can get remote full access control of the kid's watch. So this is the result. The first Wuyuan attack is our ID, and now we can see the case geolocation. We can get the we can now keep watch on the case activity and abduct the case anywhere. If the criminals found this vulnerability, it will be. So now comes the conclusion. First, developers should pay more attention to remote attack surface. And more and more remote attack surface will be discovered by hackers. More and more remote attack will take place from device to device, such as from Android phones to IoT device, and from desktop computers to Android phones, and so on. So, any questions?